For the rest of the day, we're going to be talking about dynamic media facilities and some work that the EBU has come up with, talk about security around that, relate that to some work that the VSF has been doing in its GCCG group. And to kick that off, we've got Felix from CBC Radio Canada. Felix, thank you.
Thanks very much. Exciting times. We're just done with a major facility building in Montreal. We are on air since 2020. All IP 2110, and it works at scale. And now the reason why we wanted to do this IP transition, of course, we wanted to have some immediate benefits, reduction of wiring, it's drastic. We wanted also to be future-proof with the ability to evolve to new formats, UHD in mind. This building is able to do that when it's needed by the production. Pooling of production resource, that's also something we can benefit already when we do special events like the Olympics, like the election. We can reorganize how the replay server or how the multi-viewer are used. So that's a huge improvement. And finally, we wanted to leverage IT innovation. And we already see that because the whole building in Montreal is done with 100 gig backbone. And now that we're doing a new facility in Toronto, we are, for the same price, installing a 400 gig backbone. So already a lot of benefits with the evolution of that industry. But when we did that transition, really it was a first step to the real end goal of all of this. So the transition from SDI to IP or from baseband to IP was more or less an enabler for the transition towards software-based facilities. And this is really where we will get the benefits. I'm not sure, is it cutting or it's good? Okay. So the benefits of flexibility that we really want to have, not building the whole facility for the worst case, will come with really using software-based and dynamic facilities. And this needed to remove the dependency on physical interface before we can get there. So the really final benefit is to allow agile software-based products. And in Montreal, it's really partial where we could get. A little bit of our master control room is in play out is done in software, but mostly on bare metal. And most of the live production facilities still done with electronics, FPGA for low latency, for the kind of performance we needed. At the time we built that. So on air in 2020, but we started the project in 2017. So the project in Montreal was really to do that, prove that we can do a large-scale facility with IP. Now we have the refurbishing of the Toronto building headquarters, and this is where we want to go to the next level in terms of software-based facility. So Front Street in Toronto, that's a building that was built at the end of the 80s, put on air in the 90s. One of the first doing SDI, actually, with a very large-scale matrix router. The project is a brownfield in this case. It's not a new building. It's a refactoring of the whole radio, TV, news, drama, sports, master control playout for the English network. And it will span over 8 years. So that's totally different dynamics than going into a brand new building. François Legrand is heading the technology side of the project. And one of the quotation is, he has no crystal balls we can tell him what will be the need of the production in the next 10 years, and not even very soon, because the evolution of the media business is going very fast, and we already are turning up fast channels and changing a lot of the ways production are done. So this needs for flexibility is more than ever, and we need to have this included in the project, with a first step targeting 2026 Olympics, which is in a bit more than a year. The other reason why we want to leverage the flexibility of software dynamic facility is we have a good number of regions. We have 88 radio stations, 27 TV stations across the country. And there's also a cost pressure. We need to produce more to reach the local audiences, but we don't have more money. So we want to centralize some of the resources, use the public cloud, also to be able to expand those capacities. So there's also a long-term goal in terms of the regional presence. So here is the vision, what we want to do in Toronto. It's leveraging the IP connectivity, but really expanding on the whole IT stack, fully software based. And it's based on a number of principles. First of all is a total separation between the production area, the operator positions, and the shared production resource. By doing that, we can really decouple the kind of physical interdependencies between these locations, and we can really leverage the flexibility of the infrastructure. Common routing is using IP as the infinite, like any-to-any matrix in the system, so we don't have physical constraint of what can be connected to what. A limited number of protocols, a limited number of formats to increase interoperability. Software-based solution on CUTS hardware. And finally, and this is probably the major change for production business, is no fixed or permanently assigned or reserved resource. So everything is a common resource that can be booked, reserved, operated, and disband depending on the need of the production. So another way to look at this is starting from a typical production workflow. So left to right, where we have a number of sources, a number of baseband or 2110 signal. We call it kind of legacy signals. Even today, 2110 is legacy. And also some output, some results, either for local monitoring or the program output of this. And all of those functionality being the video mixing, the audio mixing, leveling, graphics, multi-viewer, the receiver function, the encoding and transmission function, all of this can be done as a software nowadays. If we represent the same function boxes into a layered model, we have those media functions here. They can be run on different computer nodes, some together on the same nodes. You can have a cluster with a number of nodes that can run all your facility. And this is all using standard IT technology and using shared memory as a way to exchange between all those functions. So the media functions are basically a number of small software components. Of course, from multiple vendor. That's the ultimate goal. We don't believe that a single vendor will be able to provide all the functions for the kind of business we are running. So we want to be able to select which one we are going to use. and the distribution across multiple nodes to achieve the scalability we look for. Then the techniques, the IT techniques we want to use to achieve that. Of course, traditional IP streams interconnections, because a lot of time you may have multiple clusters, or you want to be able to connect to the cloud, or there will be remote contribution. It won't stop tomorrow. There's also certainly will be a number of legacy boxes that can only do that in hardware. You need to interconnect with those boxes. So this is still a strong presence of this interconnectivity, but since it's based on IP, it's not dependent on the hardware connectivity, the specialty interface. Software component exchange. So the shared memory seems to be a very good approach, since all of those functions already are using memory to do their processing. So why not sharing the outcome, the output of these functions, so that the other functions from different vendor can directly tap into them, and leveraging also IT technology to exchange this shared memory across multiple nodes with a high performance networking. So the main benefit of memory exchange like that is the fact that you can work asynchronously, and therefore you don't need to build up latency in a workflow. As soon as a few lines of video are processed and available, they can be processed by the next up in the line directly. So there's no need for waiting for a full frame of processing, and there's no need for a synchronous pipeline on this. So that's a theoretical vision. Now, how can we do it? We worked together with the EBU for the last few months to try to present that user vision to the industry. And that's a paper we published just before the IBC. It triggered a lot of discussion during the IBC. And it goes through a number of use cases, like I showed some example. Talks about the whole workload lifecycle, so the dynamic nature of this facility by reserving, provisioning resources as you need them, and releasing them, and all of this. There's also a layered model that explains the roles of different components in the system. And we propose a minimum viable product approach to get started with this, and this is something I will cover more. So the life cycle explain the different steps from designing, planning resource, provisioning of those resources when you need them, the configuration, the lifetime and the operational lifetime of the facility, and then the tear down stage. So this is all explained. But the main interesting part is this layered model where we can see the different layers, especially those at the bottom of the stack are coming from the IT industry. So we don't need to reinvent that part in terms of infrastructure, platforms, container platform. There's a tons of options and possibilities on the market. What we need to discuss here is the industry specific parts. Of course, the media function is coming from the media specialist vendors. This is where we have the expertise. In the stack model, we have a distinction between media functions, which are more elementary functions, and applications that will be built out of a number of functions. A mixer could be a function, any transformation function or encoding, decoding can be a function, but they can be built together, part of an application, providing user interface for the users. The main part I want to talk about is the media exchange, is how those media functions can exchange media in a single cluster. So that's the concept view of what we want to do at CBC and how it match the EBU layered stack. So it's exactly fitting the model. So again, our main goal is multi-vendor. So here, when we look at the same stack, on media function and application, we know we have a number of vendors. Many of you in the room can provide things on that layer. And on the bottom, as I said, there's a lot of possibilities in terms of CUTS technology, network, compute, NIC, GPUs, the cloud providers. And again, this could be something on-prem or in the cloud or a combination of both. That's also a very wide industry, and up to the host platform like the different OSs and the container platform, which has a number of tools that can be used. Coming back to the media exchange, there's also a number of options on the market. So those different platforms are not all the same. Many offer much more than just the media exchange layer, but they touch on this media exchange layer. And what I wanted to illustrate here is to see that this is a place where we have, as of today, a number of options, but ultimately we want to have a common approach to that layer. Media exchange options, a number of options here. Does it ring a bell? Does it remind you a situation we were a few years ago? In 2014, around it. So it was pre-2110, and a number of people in the room worked very hard to get a common approach to this transport question. So we could see some similarities. 2014, and when we built a building in 2018, 2019, although 2110 was there for a couple of years, it was still not very mature. It required a lot of work to get it working in 2020 when we went on air. So it takes a number of years to move from a situation where we have many different options and we can agree with the industry on a common way, and then where we can finally have user making major projects and therefore buying products solution. And just to illustrate that, we just finalized a tender document where we asked the market for media functions. So we were not asking about the platforms or the media exchange itself. We were asking vendors, what do you have as media functions? So of course I cannot give you any names, but I can tell you that we asked for 30 different media functions, and we were also asking what of the current platform are you supporting? So for us, it can help to understand what was going on. So we got 12 vendors who qualified to the minimum requirements, and that we can open and really look at them. And 170 media functions were proposed as available now. I'm not even talking as those who were in development or eventually available. So we see we already have a good pool of media functions in the market. But only 3 of the vendors proposed their own platforms. Yes, we work using our own platform. None of the other 9 said we support one of the other platform. So that's what helped me to say that we need to unlock this situation very quickly, because we have possibilities to do a lot of business here, and for us to have real production environment with this, but we need to solve that a little bit. So I believe that the industry awaits a clear direction before to invest massively in developing for a certain approach. So the priority becomes, let's find what is that common media exchange to enable the interoperability between multiple vendors. It certainly has to be vendor neutral, that's supportable by any media function developer, that is supportable by any compute and network vendor, either on-prem or cloud providers. And also it needs to match the user requirements. So another view of the same stack, we see the media functions, and then you can imagine media function A could be a generator and it produces a flow. Then media function B on the same compute node could be a processing of that flow. So it reads it, makes some change, write it back in memory. And on another node, you could have a mixer who can read two different flows and build a new one out of this. The memory shared on the infrastructure layer. So it's a number of memory spaces that are reserved to have the flows in memory, and also some mechanism to share that memory between the nodes on the cluster through the network. Just to help being a bit concrete, think about direct memory access or remote direct memory access, RDMA, could be example of that. The media exchange service, what do we need to achieve this interoperability on that layer? So this is where we zoom in one of those purple box. What are the different facets of interoperability? We need a media exchange read-write API, so a common way that application writer are writing for one API. A reader-writer function, so there's something that needs to do the job. A common frame buffer data model, that's key that all the data in memory needs to be formatted in a way that's it's readable by the others. And shared memory methods, because probably we need different ways to when it's on the same node or when it's on different nodes in a cluster. But ultimately, in a system, you need to have the same shared memory method for all the functions. And then, of course, flow registration API, connection management API, need to discover those flows, be able to address them at the right place on the network. So the part of the media exchange that needs to be, that is really media specific, that we need to agree as an industry is on the top part of this. The shared memory access, there's already a number of technology on the IT world, so we could leverage that. So this is where my proposal and CBC's proposal is a bit different than how we work until now on these kind of problems. We could work on agreeing on a number of parameters and cover all the different cases. What we propose is this time let's start early and write a first open source implementation for a minimum viable functionality. Let's pick one format of audio and video, reuse code that is already existing open source, and just what we need to get started. And it won't be the final solution. We will discover a lot of things on this, and there's better ways to do what will be done here, but at least we can get started and we can learn, and eventually this can crystallize and become a more standardized approach. And what will be important by doing that is to agree that everything we do is to start quickly. Is we could trash it at some point. We could say it doesn't work and let's start over with something else. Mike.
Would you include ancillary data in your minimum viable?
I would not. So the question is if I would include ancillary data. I think we will not necessarily include it in terms of it's not what we need to get started with the first prototype, but it should come very quickly as a second phase, especially for some types of ancillary data that we will want to use. Okay, another perspective on why should we take this approach of building it before make a standard and talk over it for a period of time. There's a couple of examples in the market. This doesn't match perfectly what we try to do here, but it gives some indication. SRT is an example of, okay, it's developed by one vendor, but it was published as an open source, and this helped the broad adoption and the interoperability. But some vendors also, because it's open source, because the recipe is known, some vendors have done their own implementation, maybe better, maybe more performant, that is compatible with the open source. So that's why to have an implementation to start with can be beneficial. NDI is another one. Of course, this one is even more close. It's one vendor, it's proprietary. They license SDK. The benefit for endpoint is to implement that SDK directly. It guarantees the interoperability and to keep up to date with the improvements. We propose to do it open source and non-developed by one vendor. But the idea of an SDK or something that exists and can be used into product to bootstrap the development and to unlock the kind of chicken situation where we will have otherwise. All media function in a cluster use the same media exchange. That's key. That's what's below the media exchange read-write API. First phase an open source implementation, but we can understand that this won't be the best implementation. So vendors can make their specialty of developing alternative implementation. But once we have this open source reference, we have the benchmark to test those alternative implementations. A vendor can offer a technology that's taking care of all those things and do it better, more resilient, more that they will support their implementation. That's certainly a business for this. But again, it's to start early and quick with a common denominator. So what would be in that open SDK? Media Exchange Read-Write API. John will present in a few minutes what the cloud, ground, cloud, no, that's the other way around, I guess, API is working on. But also take a moment to go back in time and look at what AMWA Agile Media Blueprint Content API was about. It was published many years ago, and there's a number of good ideas of how this could look like. Also, the BBC Time Addressable Media Store API, it's meant for file in that case, but we're really in a case where frames and files is start to be very similar. So those are examples of how can we address frames or chunks of audio in a frame buffer. Reader-writer service, it could be a reference implementation that's included in an SDK. Common frame data model, that's where we need a specification to agree on how we form those frame buffers. Common shared memory methods library, so ideally everybody use the same library. So in terms of interoperability, especially at the beginning, we don't need to run huge interrupt events or a very tight specification. So we could start with something existing. And of course, flow registration and connection management. We could leverage NMOS, for example, with including some reference code, how it will work. Maybe these specs needs a little bit of modification or extension to support these use cases. but that will form an SDK that vendors can start already to try out and learn, and then we iterate, and at some point when we get some stability, we declare victory. In terms of user requirements, the common frame buffer data model, for example, what CBC and DB we're promoting is, let's pick one video format. Maybe the approach can do any video format or many video format. Let's start with one and test with this one. 1080p, 5059 to be international. 422 YUV 10-bit is very widely used. And one audio format, 24-bit, 48 kilohertz audio. But actually how it's formatted in memory, the grain payload, the requirement really, it's meant to be efficient by processing, computing, CPU, GPU, memory exchange. So probably something like a number of bytes. So now that's a good point. It means that we need to have a way to carry 422 10 bits, but it could be RGB 444 16 bits per component. This would certainly support that use case. So we don't want here to enter in the discussion, is it P groups, is it V210, is it something else? But we want to make sure that this is meant for the application, which is direct access of memory of applications. Asynchronous access as soon as available. Downstream media function can already start to process when they have it. But then for this, we also need a very good data model of flow identities and timestamps, so that when you need to realign essence together, audio and video, you need to have all the information necessary to be able to do that. Probably we need, if we want to realign audio flows together, we need a very good precision, microsecond precision. So probably PTP is still a very good way of getting there. Format description, metadata. Please make this one self-describe. We've run through the adventure of having separate sidecar to carry the information, the format information. We have an opportunity to include that and in the memory frame buffer. And to have a certain retention of that frame buffer, we're talking about live application and doesn't need to be very long. But let's start with something like 1 second frame buffer for all flows. And on the common shared memory methods, let's start with something that's already exists, that's supported by many compute network vendor, cloud providers, extensible, if not all of them are there, something like LibFabric maybe. So what's next for us? CBC, we aim at being using that type of technology for the Cortina Olympics. That's tomorrow. And then the whole building in Toronto will leverage all of this. EBU Dynamic Media Facility is working still on their reference architecture with all the discussion that happened at the IBC and that are still happening, and with a focus on the user requirements. Again, the exact solution of this, I think it has to come from a wider discussion with the experts, and the vendors are certainly can provide a lot of expertise in this field. So the user will focus on the user requirements. And EBU plans to hold a user meeting with industry guests in November to see how we can move forward with this topic of a common media exchange. Bang.
Any questions, comments? Well, do these microphones. Some of us remember being in a room when we talked about what would we do if SDI wasn't here anymore. And I think this is an equivalent kind of inflection point in the industry. So thanks, Felix, to you, the EBU colleagues, for bringing this up. For other people who aren't in the room, Richard Cartwright, who's been pushing this for a long time, and Gordon Castle, and a number of others. So, yes, sorry, hold on.
If we want to get invited to this EBU meeting, what do we need to do?
You can talk to me.
There you go. Okay, great. Felix, thank you so much.